Here's our Senior Design 2 poster made while working with Dear Hitachi. Please go through the following slides to get more in-depth information on each topic. This senior design project is done in partnership with Dear Hitachi. Our team is trying to reduce manual labor, specifically in the welding process at the plant, to improve process flow and quality. Currently, transportation processes are done manually, and our goal is to automate that process by researching and analyzing Dear Hitachi's current process and then designing a replacement system using AGVs or automated guided vehicles.
Here we have our specifications and deliverables. For specifications, the AGV transportation has to have a cart in length of 4,700 millimeters, a width of 1,445.8 millimeters, and a height of 1,317 millimeters. It needs to have a capacity to weigh up to 6,000 pounds. For the deliverables, we have the research use of AGVs in factories along the companies that manufacture them, 2D layout of process flows with AGVs implemented, documentation on expected return on investment and improvements, 3D simulation of AGV recommendation to test and verify design, and lastly, if possible, to find a cooperating AGV vendor to lend demonstration materials to implement a test of the team's design.
New material handling process, we first made a decision matrix evaluating the 3 ideas that we had come up with. We decided to go with idea 3, which was a new part layout with an AGV system implemented, which then allowed us to create a decision matrix determining suppliers that we had communicated with. We ended up having Fori and Eckhart as our top 2 suppliers. So we then had to make changes to the current process. One of the changes that we needed to make was to the cart. You can see that we raised the understructure to allow for the tunnel AGV that we selected to pass underneath and connect to the cart in order to move it.
This slide shows the changes for the current process for when we have the leased AGV or loaned AGV for about 3 weeks. This includes some magnetic tape, protective covers, and certain sensors. And below is a layout of the current process or current parts. And if you look closely to the layout, there's 4 green boxes, and these areas indicate where we have rearranged parts to make it more efficient.
On this slide, you can see the simulations that our team did in order to get an accurate view of what Dear Hitachi's process would look like with an AGV implemented. The first simulation we did was of the current process. This gave us a baseline of data that we could compare to the data we got from the implementation of the AGV. As you can see, the kitting associate utilization in the current process was 37%. Then with the AGV process, that dropped down to 30%. The reason for this was because the AGV is now doing all the transporting of the kits. So the kitting associate is freed up from other tasks, which backs up the idea of using an AGV in this process.
Here on this slide, we have the return on investment, known as the ROI, for Fori Automation and Eckhart. The total cost of implementing one AGV from Fori Automation is $261,164. The return on investment is 7.3 years. For Eckhart, the total cost of implementing 3 AGVs is $848,218. The return on investment is 23.8 years. In total, implementing an AGV will save 1,430 hours of direct labor costs from Dear Hitachi employees.